morning, good afternoon, and good evening. Thank you for joining us today for our hands-on workshop, Do You See What I See? Using augmented reality and artificial intelligence. Let's get started. We hear the terms AR and AI used around a lot these days, and these technologies have begun infiltrating our daily lives. From Alexa and Siri on the AI side to Oculus Rift and Kinect on the AR side, these technologies are changing the way we live and work. Typically, AR and AI have been used separately, but they can be used together as well. In this workshop, you will learn some key concepts of AR and AI. We will also discuss the challenges associated with using these technologies so that as you begin applying them to your work, you can do so with your eyes wide open. As Helen Keller, who was world's very first deaf and blind person to receive Bachelor of Arts degree, said, "The only thing worse than being blind is to have sight but no vision." Now, with this background, let me introduce myself. I am Shruti Karulkar. I am Quality Engineering Manager at Mathworks. And today I am thrilled to be talking about augmented reality. Over to you, Sarah.
Yes, thank you, Shruti. I'm Sarah Mohammed, and I'm a software engineer on the statistics and machine learning team at Mathworks, and I work on deep learning interoperability. So today I'll be talking to you all about artificial intelligence. Over to you, Lou.
And hello, everyone. Welcome. So my name is walker-hannon. Feel free to call me Lou. I am an application engineering team lead, and I typically work with a lot of customers who implement AI as a part of their workflows. Today, I'm going to highlight information regarding challenges with AI and AR. Thank you so much, and back to you, Shruti.
Thank you, Sarah and Lou. So let's talk a little bit about logistics. So for this workshop, you will need your desktop or laptop. You will need your webcam to do hands-on exercises and be connected to Wi-Fi. Throughout this workshop, if you have any questions, please do not hesitate to ask those questions via the chat window. We have a team of our power TAs joining us today who will do their best to answer any questions you might have for us. So please do not hesitate to ask any questions. We have a short pre-work for you, which shouldn't take more than 5 minutes. A link to this pre-work would be given to you in the chat window by one of our TAs. If you haven't done the pre-work yet, that is okay. You don't have to do it right away. You can do it as and when we get into the hands-on portion of this workshop. Let's talk a little bit more about logistics. For doing the hands-on exercises, you are going to use MATLAB. MATLAB is a programming language used for scientific computing and engineering. Today, you are going to access MATLAB in your web browser. We call this technique MATLAB Online. You will have access to MATLAB Online and all the tools that we are going to use today for the next 1 week. So make the most of this opportunity to explore AR and AI even further using MATLAB. Steps to log into MATLAB Online are given in the pre-work, which will also be given in the chat window. Talking a little bit more about logistics, let me set your expectations. We have a lot of material to cover in the 45 minutes that we have today. Hence, it won't be possible for us to write all the code from scratch. Hence, we have exercise files ready for you, which can be accessed using the link shown here on the screen. This link is there in the pre-work and also would be shared in the chat window. As and when we get into the hands-on portion of this workshop, we will go at the high-level code so that you can understand how things are implemented. Okay, so now let's see what's the agenda for today. We are going to begin by talking about augmented reality. Next, we are going to learn some key concepts of artificial intelligence. And last but not the least, we are going to discuss the challenges associated with applying AR and AI to our work. Now, with this background, let's dive into the first topic for today, which is augmented reality. Before I give any formal definition of augmented reality, I want to hear from you. So let me know via the chat window. How many of you have heard or played the game Pokemon Go before? Anyone? Okay, I think a few of you have. So the good news is, those of you who have played this game before, you have already experienced augmented reality firsthand. Pokemon Go is a game in which a Pokemon or a character appears on the screen of your mobile device on top of whatever your device is looking at. Augmented reality is nothing but digital information superimposed on users' view of the physical environment. Now let's look at a very simple example of AR. So this is me. I was in my study doing some experiments with MATLAB and webcam. And my experiment was to make certain objects appear on the snapshot taken by my webcam. So the birds that you see here are nothing but digital information that has been superimposed on what my webcam was looking at that point in time. This is the simplest example of augmented reality. Now let's look into some real life examples or applications of AR. And I should tell you this, AR is no longer the sci-fi future, but it is today's reality. With the COVID-19 pandemic, AR applications are becoming more and more prominent in our day-to-day lives. Now that we have social distancing guidelines and travel restrictions, it is more difficult than ever to get experts in front of systems that require specialized knowledge. Now, this can happen at a manufacturing facility or at an hospital. Organizations are increasingly seeking AR as a way to train frontline workers so that they get all the necessary training without having to travel anywhere. On a lighter note, AR is used to have virtual fitting rooms where we can try outfits from comfort and safety of our homes. Interior designers and architects have been using AR to visualize the final design and product. Today, the good news is you are going to implement AR. And to do so, you are going to use a technique which is called segmentation. Segmentation allows us to separate an object from other object, from an image or a video. Segmentation is done based on certain criteria like differences in shape, size, color, texture, etc. Now let's move on to our first hands-on exercise, which is also a demo. Before I go into the code of this exercise, I want to tell you what's the goal. What are we going to do as part of this demo? The goal of this exercise is to use your own webcam to take your picture and to change your background. Like you see me now, I have a virtual background. For those of you who might have been using Microsoft Teams or Zoom, this feature might sound familiar to you. And that is exactly what you are going to do in the first exercise. Now, let's look at the code that is going to help us achieve this. We have several options for backgrounds given to you. You can choose any one that you like. Next, we have a while loop in which we are going to continuously take snapshot using your webcam. Next, we are going to use a helper function to perform segmentation. This function produces a mask which defines which pixels in the image are you versus which pixels are the background. Next, we are going to use another function to superimpose you on the new background that you are going to select. And finally, we are going to display the new image. This is our code for our first exercise, our demo at a very high level. Next, let's see how we are going to execute this code. Log into MATLAB Online. Once you do that, go to the file browser and locate the file named demo.m. Open this file in the editor. Then locate the Run button on the tool strip and click that to execute the code. Once the code starts running, you will be prompted to select a background. Select any that you like. My friend Sarah here selected Apollo 11 background, and this was the output that she got. Let's see what kinds of output you get. I have two things that I would like to say here. First is, as you execute this code, the first time that the code is run, the performance of the model is slow. The performance of the model gets better on the second and third run. So if you get a chance, try and run this code multiple times. You should be able to see improved performance. Second thing that I would like to say, throughout running this exercise, if you run into any issues, please do not hesitate to ask questions via the chat window. We are going to take 3 minutes to do this exercise. It is 11:58 Eastern Time. Let's regroup at 12:01. Let's get started. We have 1 more minute for the exercise. Okay, it's 12:01. Let's regroup. How many of you were able to run this exercise? Few of you. For those of you who weren't able to run this exercise, it is okay. You will have the opportunity to run this code again as part of the next hands-on exercise. So we will help you to debug any issues that you might be running into. So it's perfectly okay. So for those of you who were able to run this exercise, I want to hear from you. How well do you think the algorithm performed? Were you happy with the segmentation results that you got? Do you think the lighting in your room, the resolution of your webcam, do you think that will impact the results? I think definitely. These are good thought-provoking questions that you should follow along and think in this direction. This will help you explore AR even further. Now with this, let me hand it over to Sarah for the next topic for today, which is artificial intelligence. Over to you, Sarah. Let me stop sharing.
Thank you, Shruti, and I'll begin to share my screen. All right, everyone. Hopefully you had the chance to try out the segmentation demo. But again, even if you didn't, that's okay. There are more exercises to come and you'll have a chance to try running the code again. In this next section, I'm going to talk about some of the methods that drive AR and VR applications. And it turns out that in the demo that you just ran, you were already using some AI behind the scenes. And we'll talk a little bit more about that. But first, what do I mean when I say artificial intelligence or AI? It's usually easy to think of it in terms of examples like self-driving cars or being tagged in your social media post automatically or your smart home devices. And these all fall under the AI umbrella. You can think of AI as being a tool to build systems that can automatically accomplish tasks in what we would think of as being a smart way. And that can include a very broad group of techniques that are used across many different industries, from manufacturing to agriculture and even, as you'll see, to AR. But let's talk about some of the more common types of AI. There are two common terms that you've probably already heard, machine learning and deep learning. And deep learning is a type of machine learning. So we can define machine learning as the practice of learning a task from data without relying on a predetermined equation or model. And in other words, this means that we don't have to sit down and write business logic or if-else logic to try to code the behavior that we want. And deep learning takes this a step further because not only does it not rely on a pre-programmed formula, it can also learn how to solve a task directly from raw data like images, text, or sound. And we'll discuss what that difference means by talking about the workflow for each one, starting with a machine learning workflow. So one of the steps that separates machine learning from deep learning is called feature extraction. And we can explain it using an example similar to what you'll do in the next exercise. So let's say that you're building a game that can classify what pose someone is making. Perhaps the data that you have are photos, snapshots taken from a webcam. You could treat every one of the pixels in every photo as being a feature, but that would be a lot of features, and you might not have a lot of success with that. It might be more successful if you could derive some meaningful information from the pixels in each photo. So for example, what if you could determine the coordinates of a person's joints in the photo and then use those coordinates of their joints to determine whether someone is, for example, dancing or standing or waving or doing something else. And it's that process of deriving the information that will be used to teach a model from the raw data that we call feature extraction. And the features here, I'm choosing manually, right? I might decide that joints would be a good feature. So for someone who's a real world engineer who's trying to implement a machine learning algorithm, you would need some sort of domain expertise about both the data that you're using and the problem that you are trying to solve. So that would be one obvious place where you'd have to inject some of your understanding of the problem. You know, I'd be using my knowledge or my lack of knowledge about what is important to do pose detection here. So what might happen if I just chose unsuitable features? One possibility is that maybe the model just doesn't perform well. It's not accurate enough. But in the worst case, maybe the system would misbehave in an unexpected way if it were deployed in the real world. So in deep learning, we said it's different from machine learning in that it doesn't involve that manual feature extraction step. So rather than selecting or engineering features from the raw data, a deep neural network can learn from the raw data itself. So I'm not looking for specific properties of my data manually. I'm giving those raw images, for example, to the model to learn. And this is one of the advantages that's made deep learning so popular in recent years. And it's been demonstrated to be especially well suited to tasks with images. So what exactly is a deep neural network or a neural network, and how exactly does that work? You can think of neural networks as being architectures that are inspired by our own brains. We have layers of neurons that are all interconnected. And you can think of the strength of the connections between these neurons as what's learned based on the data. So the pathway that gets fired or activated when you pass a piece of data through a trained neural network is what we might consider a feature. So not having to extract features manually is an attractive property. You might think, Okay, if the features are learned automatically, does that mean that once I have a trained neural network, it hasn't been injected with my understanding or my bias about the problem? And no, that's not quite true, because I'm still deciding a lot of other factors, like the architecture of my network, the data that will be used to train it. I'm just making a decision about the task it's being designed to solve in the first place, and whether it's even desirable for a machine to be solving that task at all, among lots of other decisions. So there's really no escaping that bias, although I might try to identify and counteract it if I can. So in the next exercise, we encourage you to try to look for some of the manifestations of some of that bias. And you can ask questions like, well, how was this model trained? Using what data and for what purpose? So in this next exercise, you are going to use a deep neural network to classify your pose into one of 5 different categories. And there are systems that are out there already using technology like this. So for example, in sports, pose recognition can be used to track the motion of an athlete across a field. And in robotics, there are more specialized systems like this for just hand recognition for remotely controlling robots. And there are many other examples across other industries as well. So let's take a look at the code for this next exercise. These are highlights again. First, you'll be prompted to select some labels for the different poses that your model will classify. And then similar to the last demo, we have this while loop that will capture snapshots from your webcam in a loop before passing that image to a classifier that's been pre-trained already to identify those 5 poses. And then you'll see a plot with the results along with the classified label and the score. So let's go ahead and open up the file exercise1.m. And again, click on that run button to start running the code. After you hit the run button, you'll be prompted to name the 5 poses, like I just said. And you should also see an image pop up that demonstrates each one of the 5 poses before you label it so you can see what it looks like. So just hit the return or enter key once you've typed each label in the command window, and then the code will load the classifier and start your webcam stream. So try out each one of these 5 poses and take a look at the label and score and let us know how things are going in the chat as you go along. We will take 3 minutes for this exercise. So right now it is 12:09 p.m. Eastern time. So we will go ahead and reconvene at 12:12 p.m. Eastern time. All right, let's go ahead and start. All right, everyone, let's go ahead and reconvene. So after you ran the code, hopefully you were able to run it. How were the results? Did you notice, for instance, that some labels were more easily classified than others? Did you notice whether any of the factors from the demo, like the resolution of your camera, how you are positioned relative to your webcam, did any of those factors affect the results that you got? Let us know in the chat window how that looked. We're going to use something similar to this exercise in this next section, where we talk about some of the challenges in implementing AR and AI together. So Lou Vera is going to walk us through that section. So I'll go ahead and hand it over to Lou now.
Thank you very much, Sarah. And give me a few seconds while I switch over and share my screen. Thank you. This is interesting. Okay. Let me see. So I just wanted to check. So can you see the presentation at this stage? Anyone?
No, we see team. Yeah, can see it now, Lou.
Okay, it took a few seconds to refresh. Thank you, Shruti. Thank you, everyone. Okay, so we're now going to continue and look at challenges with augmented reality and artificial intelligence. So as a part of what you've seen previously, you've seen information about augmented reality and artificial intelligence presented separately. Now you'll look at this information in terms of using these technologies combined. But why are we doing this activity? Well, one of the items is increasingly there are more applications that may be in the process of exploring both of these technologies being used together. And there's a lot of motivation for doing this type of exploration. For example, we have this application here where an individual created a deep neural network to classify poses that were identified as being violent. If we look closely at this particular slide, you may notice that it highlights that a deep neural network used 14 key points in the human body to identify poses in a variety of categories. One of the categories that stands out for me is kicking. Now, there are a lot of questions that may come up related to this application. For example, here's the question that's on the slide. Could some of these perceived violent poses have a different meaning in other environments? And my answer is yes. And here's just one example. So if you see someone kicking on the street, it may cause a certain reaction from many of us. However, if someone was kicking in a gym, that actually may make sense. So whatever someone is doing in terms of their behavior is context dependent. And in order to change this context in this case for this workshop, we were thinking about combining augmented reality and artificial intelligence to see the following. If we change our scene, does that change the classification of our poses?
Excuse me, Lou.
Yes.
Would you mind sharing presentation mode? We need
Okay,
your
sure.
notes
I was
mode.
sorry about that. I was
No
asking
problem.
people to let me stop sharing. I was asking individuals if we could see or not. Okay.
Yes, we could see you, but we were seeing your notes. There
Okay,
we
sorry
go.
about that.
Thank you,
Okay,
Lou.
perfect. Thank you. Sorry about that. Now, in terms of the next exercise, what are we going to see? So we're going to see the following. So I'm going to walk you through the code first, then I'm going to exit out of the presentation to show MATLAB Online and what you can do to run this exercise. So we're going to look at an overview of the code, just like you've done in the past. So in order to get prepared, please visit the MATLAB Online environment, and we're going to visit the file with the name exercise 2. I'll show this to you in MATLAB Online in a few more minutes. So the first part is we're going to have definitions for various labels. Those labels are for the poses and for the various backgrounds we have access to. We also have a prompt to ask all of us users to prompt for the background. So select a background. Now in the body of the while loop, what do we have? We're going to take a snapshot from our web camera that's going to identify and gather which poses we're trying to do. That little hand movement was trying to show poses. And then segment the user from the background, superimpose the user on top of the selected background, and try to classify a particular pose. So we have all of the instructions that we're going to see in action, but I'm going to actually exit out of the presentation and try to show you where you can find things like the run button and opening up the code in MATLAB Online. So please give me one quick second while I exit out of the presentation, and I'm going to visit MATLAB Online. As a lot of us can hopefully see, and let me check again, can you see the MATLAB Online screen that I have up and running? Can anyone verbally give me a recommendation?
Yes.
Yes.
Okay, or some sort of feedback. Thank you. So here we are in MATLAB Online, and I believe a lot of us have MATLAB Online up and running. So if you can give us some feedback in the chat, that's helpful. And in the current folder window, I happen to be in this folder that has the dedicated exercises for this workshop. And in my case, I'm going to visit exercise 2. As a few of our colleagues from Mathworks pointed out, you could double left click on this file. In my case, I could actually right click on the file, and in this case, select open. So what is that going to do? This should help me open up this code for this file exercise 2 in the MATLAB editor. If you look closely at the top of my window, what you may see is there's an editor ribbon. And as a part of that editor ribbon, you'll see quite a few different categories. And in my particular case, I'm going to show the category run. Why? So we can get access to the run button. So in order to run this code, and some of you may have seen these instructions before, once this exercise 2 file is open, we can left click on line number 1. So we have an active cursor in that window, and we can press the run button. Now, a few small reminders for some of us. So keep in mind, you are going to be using a web camera. So make certain you have the web camera available, and also you're allowing MATLAB Online to use the web camera as you're running this code. So with this in mind, we're going to take a few minutes for the exercise. Right now it's 12:20 p.m. and we're going to take them until 12:23 p.m. Eastern time to do this exercise. If you have any questions, please ask your questions in the chat. Thank you. I'll stop sharing and return to the presentation in a few seconds, but please do the exercise. And then I'll check in about the presentation in a few minutes. And I see a few questions coming up in the chat, and I'll just try to answer some of them verbally as we're going through the exercise. So no, we do not want you to open up as live script. So that's fine. In terms of allowing MATLAB to get access to the web camera, you'll typically see a prompt when you start to run the code. So it may be a prompt that you'll see according to the supported browser that you're using. And as a reminder, we're using the Google Chrome browser. Thank you. And I'll try to answer some of the questions verbally if that helps out. One small note, there are some exercises that do not require the usage of a web camera. There is a separate folder for those of us who may not have a web camera. And for those of you who are waiting or looking at my screen, can you see the presentation itself and not any notes? A verbal confirmation would be helpful.
Yes.
Perfect, thank you. And thank you to my colleague Hada, and we have a few seconds left to do the exercise. So in terms of the exercise, I'm looking at the time. So right now it does tell us that it's 12:23 p.m. Eastern time, and we're going to continue. So we're going to reconvene. Thank you to Hada for the message in the chat as well. So in terms of the exercise, I hope many of you could do the exercise. And if you'd like to share any feedback about the exercise, please feel free to write a few comments in the chat about your experience with this exercise. Now, as a part of this exercise, one of the major themes that I think of is, well, I'd like to go through these questions. So how well did the algorithm segment the user, so us, from the background? How does the lighting, resolution, and other factors impact the classification results? Also, did the classified results fit within the context of the scene where you were located? And I think these questions actually lead to other questions. For example, we know some of the poses were not classified correctly, but also, once again, based on the scene, does the pose fit the context of the scene? Then it leads to even more questions. Who was involved with determining how a pose should be classified? As well as the following: what is our responsibility as we not only create this technology, but as we test the technology and use the technology, which can have very severe real world consequences for other human beings? And this leads into the topic of exploring these challenges with AI and AR. So in the word cloud, we're going to see a few words that we should consider thinking about when we're going to either implement and or use AI. For example, for a lot of AI algorithms, when we think about how do we automate this algorithm, what are we doing in terms of identifying certain components of the algorithm and the efficiency of the algorithm, how quickly is it running? We also have what is the accuracy of the algorithm, the context in which it's being used, and also the development of the algorithm, what steps are being taken. What about the data? Is there bias in the data? Speaking of bias, you have what are our responsibilities in terms of trying to decrease bias, discrimination, and being concerned with, is there a component of justice to what we're doing with AI? All of these particular topics bring us to a few more questions that I think each and every one of us should consider. For example, all of us are impacted by AI in the world around us, and also all of us are called to action. For example, how can each of us get involved? So there are a number of organizations that are actually actively exploring what we can do in terms of AI and justice. For example, there's the Algorithmic Justice League that's run by Joy Buolamwini. And this is an organization that you could explore more to learn more about this topic. Another major theme is who is involved with creating AI. In many cases, with the creation of AI, quite a large part of the world is not involved with the creation of AI. That means there are many different perspectives that are missing when it comes to the creation and implementation of AI. And one of the things I challenge us to do is to figure out how can each of us become more involved, whether it's the creation of algorithms, the testing of algorithms, or actually questioning, should we be using AI in certain contexts in the first place? What about the data? So in many cases, many times with AI systems, there is bias in the data. And we need to explore how can we minimize bias in data in terms of the data collection process, the data mining process, and so many other factors. And finally, do these same issues occur with augmented reality? I have to admit, at this stage, I haven't read as many papers that highlight the same issues, but I could possibly see going future forward, some of these same issues may exist related to augmented reality. But I think this is going to be an area of a lot of future research. And with this in mind, it also brings us to yet another question. Can we address these challenges with AI? And I have to admit, I'm hopeful. I believe the answer is yes. I think we can, but we need to work together as a group, as a community. Now more than ever is a time to raise awareness, discuss and implement actions to address challenges in AR/AI, especially with respect to bias. One of the premier researchers on AI ethics is the founder of the Algorithm Justice League, Joy Buolamwini. And there's a quote from her that I'd like to highlight, and it gives us some ideas to consider. As more people question how seemingly neutral technology has gone astray, it's becoming clear just how important it is to have broader representation in the design, development, deployment, and governance of AI. The underrepresentation of women and people of color in technology and the undersampling of these groups in the data that shapes AI has led to the creation of technology that is optimized for a small portion of the world. One major theme that I take away from this quote is that this is a multi-layered problem that entails work from each and every one of us. And I encourage each and every one of us after this workshop to explore how can we start to think about how we can potentially address challenges with AI. And I think part of that is education, but also asking questions in quite a few different spaces and places. With this in mind, that brings us to the end of our workshop, where we'd like to point out some resources you could possibly explore after this workshop. So in terms of learning more about various topics, there is a resource that we can point you to that highlights different on-ramps where you can take free tutorials to learn about topics that were highlighted as a part of this workshop. And finally, I want to say thank you to you as the audience members. Thank you to the math workers involved with delivering this workshop. Thank you so very much for your time. Take care. We hope you enjoyed this workshop. And if you would like, we have some different ways of being able to follow up with you if you have additional questions. Thank you once again. Take care. And that is all for the Do You See What I See workshop. Thank you.